Good morning, everyone. I want to officially welcome you to today's webinar, Implementing the Latest University Research in Your Snow Mold Program, presented by PBI-Gordon and taught by Koch, Ph.D. My name is Lisa Wick. I'm the Senior Manager of E-Learning Programs here at GCSAA and will be today's moderator. We are recording today's event, and you'll receive access to that recording via follow-up email. Your audio is muted in this system, but you can ask questions as we go along. We encourage you to do that by either typing in the question answer box or clicking the raise hand button, and we can unmute you at an appropriate time. There are handouts available in your GoToWebinar control panel. If that control panel is minimized, you're going to see a narrow strip with an orange rectangle at the top. You click on that, and that's going to then give you access to the handouts as well as that question answer box. Today's session is eligible for 0.1 GCSA education points, and at the end of the program, we'll give you the code to use in the association's website so you can record those. We hope you'll find today's webinar valuable. It's brought to us in partnership with PBI-Gordon, who has a full line of herbicides, insecticides, fungicides, and growth regulators, as well as other products. PBI-Gordon Corporation is a national leader in the professional turf and ornamental management industry. We thank them for their support. Paul Koch, Ph.D., is an assistant professor in the Department of Plant Pathology at the University of Wisconsin-Madison. Koch's research focuses primarily on developing precision disease management strategies for snow mold and dollar spot in turfgrass and investigating the fate and impact of turfgrass pesticides in the environment. Koch also oversees the University of Wisconsin's Turfgrass Diagnostic Lab and the UW Turfgrass Fungicide Testing Program. Please join me in welcoming today's presenter, Paul Koch, Ph.D. Paul?
All right. Thank you, Lisa, for the introduction, and thanks to everybody for signing in. Lisa tells me we have people signing in from all around the world. So, I know it's Christmas season, and that's one reason it's the most wonderful time of the year, but it's also snow mold season. So those of you tuning in today around the world to hear more about snow mold, you're my people. So I'm excited to talk to you today about snow mold. I'm going to quick turn off my camera here, so the top of my head is not glaring at you the entire presentation today. But we're going to go ahead and start talking about snow mold. And like I talked about over Twitter a couple days ago when they were first sort of promoting the webinar today. I should have called this a snow mold smorgasbord. We're going to talk about all different types of snow mold and different snow mold aspects, but I want to start out with this poll today. So how many of you see significant snow mold at your course, and how often do you see it? And the reason I'm asking this question is, I'm located in Madison, Wisconsin, pretty much considered a harsh winter area, not the harshest out there, but certainly an area that should see snow mold on a regular basis. And in our testing trials over the past several years, we've been doing testing trials on snow mold for, I have at least for about 13 years now. And we don't often see, significant snow mold down in our area of the state. You go further north into northern Wisconsin and northern Michigan and into the Rocky Mountain West and northern New England, kind of the snow belt areas in the U.S. and then similar areas in Canada and around the world that have prolonged snow cover. Snow mold is a very significant disease that causes quite a bit of damage. Different types of snow mold that occur in the Pacific Northwest of the U.S., British Columbia and Canada, Northern Europe, the UK, Ireland, Scandinavia, those areas that don't oftentimes see a lot of snow cover but have those cool, wet conditions that lead to Microdochium can also see significant levels of disease. So, this poll result is about what I expected. A lot of people see it every year, but there's a lot of people that see it maybe once every 4 to 5 years. And that's what I would say we have here in Madison. It's about every 4 to 5 years. And so that sort of leads into the next question, which is how much do you then spend annually on controlling snow mold. So I have it up here in U.S. dollars. If you're in Canada or elsewhere around the world and want to do it in Canadian dollars, euros, or whatever, feel free to sort of extrapolate it roughly to your currency. But what I find, especially in maybe the southern Great Lakes area, the area where I'm located and dealing with superintendents in Chicago, Detroit, Cleveland, where we only see maybe once every 4 to 5 years, we still spend quite a bit of money on it. I know several people that spend $20,000 plus just controlling snow mold, and they probably haven't seen any snow mold on the golf course in 4 or 5 years. So I think where that need to control snow mold comes from is that snow mold, especially when it's under snow cover for the majority of the winter, is a disease where you only get one shot to get it right. So I feel that we spend more money than we probably maybe need to controlling snow mold. So there's several people that spend $5,000 to $10,000. Probably a good portion of those people were in that group that saw snow mold maybe only once every 4 to 5 years. And the reason we spend more money on it than maybe we might absolutely need to is that if we decide to decrease our budget and spray less for snow mold in a given year, and then that's the year that we have a pretty significant winter with a lot of conducive conditions for snow mold, we're kind of stuck. And that's one thing that's different about snow mold relative to other summer diseases. If we have an outbreak of dollar spot in the summer, we go out and we spray a curative application. We might be chasing it around for a bit, but we get it under control within a couple of weeks. Same thing with with brown patch and anthracnose. Snow mold, if we didn't get it right the first time, we're kind of out of luck, and then we're kind of behind the 8 ball in the spring. So while I say oftentimes we probably spray more and spend more than we need to on snow mold, if I was a superintendent, I would probably do the same thing, right? You want to be conservative and plan for sort of the worst case scenario. All right, so when I first designed the webinar here, I just started out in the old classic. We'll start out with an introduction into the pathogen, and then kind of go through different aspects of snow mold management. But I want to change it around today because with how cold the winter got for many superintendents in Canada and the Midwest, and how fast it got cold, there was a lot of conversation around fungicide timing. And there was a former turf pathologist at the University of Wisconsin for several decades. He retired in the 1980s, and his name was Gail Worf. And his line to superintendents in Wisconsin was, before you crawl into that deer stand for deer hunting, you better have your snow mold out. Now, for us in Wisconsin, gun season starts the weekend before Thanksgiving. So that meant the weekend before Thanksgiving, you better have your snow mold out. Now, some years that makes sense. This year, that made perfect sense for many in the northern part of the countries. Other years, that doesn't make sense. I just saw a post online from one of the local meteorologists. Last year, on this date, last year in Madison, we had a high of 65 degrees Fahrenheit, right? So that's a condition where you wouldn't want to spray your snow mold. It's going to be too warm. There's going to be breakdown of that product. And we'll talk about breakdown of the product after application in a little bit. With that cold, early cold snap we had across North America, there was a lot of questions. I had many more questions this year on this topic than I got in past years. And that is, do snow mold fungicides work if they're applied to frozen or dormant turf? All right, so the theory here is that if they're a penetrant or a systemic product, that do they still work if the plant is not growing? And we've never actually done a test looking at this specifically, but anecdotally, from some of our past work, I can tell you that they absolutely do work. And one example that I have is several years ago, we were putting out a trial in central Wisconsin at Central Road Golf Course in Stevens Point, right in the central part of the state, about an hour and a half west of Green Bay. And by accident, we were a little bit later than we intended to be, and it was frozen outside. It had been 25 degrees for a high or less for a week or more. So we were putting those products out onto completely frozen turf. There was no growth going on there in the slightest. So we had that same question that year. We actually, our booms were freezing up as we were spraying fungicide out there on those tests that day. The ground was frozen so hard we couldn't get any metal stakes in the ground to label our plots where we needed to spray the treatments. So we were interested on how the products were going to work that particular year. And what I can report, we went out the next spring and we had excellent snow mold. Here's a picture of that same plot. We had excellent snow mold, and you can see there is a ton of products that work perfectly fine. And these products included not, some of them included contacts, but many of these products didn't include any contacts. They were all, sort of DMI, acropital penetrants that need to get into the xylem to flow. I apologize, the date on the top of the slide here should be March 16th, 2011. So, so why do they work? We learn from seminars and in classes that the products need to absorb into the plant to work. So my theory of why they still work, even if you apply the product onto frozen turf, is that there is a passive absorption of the product that works even if the plant is no longer growing at that point in the year. So to illustrate that, I have this slide that's from Dr. Rick Latton's book, A Practical Guide to Turfgrass Fungicides, which, by the way, is an excellent book. Highly recommend anybody that uses fungicides in the turfgrass industry to purchase that book. You can purchase it at the American Phytopathological Society website. And actually, there's a version 2.0 coming out next year in 2019. So anybody that uses turf fungicides, it's a great book that explains fungicide activity and products and how they work in a nice, easy to understand manner. All right, back to the question at hand here, though, is that so we have this red droplet over here on the surface of the leaf blade. In the summer, when that plant is actively growing, the fungicide absorbs into the leaf tissue, kind of in between the individual plant cells. Then it gets to the xylem here in the middle of the turf leaf. And the xylem is sort of a tube in the turf leaf that moves from the roots up to the tip of the leaf, and it moves from the roots up to the tip, right? So it moves upward in the plant, and it's a travel of mostly water. And so when we say an acropital penetrant, it means it gets into that xylem and it moves upwards inside the plant. And so to have that upward flow in the xylem, yes, you do need the turf to be growing. However, if the turf is dormant, I believe that the fungicide still absorbs into sort of the outer area of the plant, here between these mesophyll cells, but it doesn't get into the xylem, right? Because the xylem is not flowing, so there's no flow. So the coverage might not be quite as good as if you would apply them in the summer, but you still get solid control, and we've seen many cases excellent control of fungicide or of snow mold applying fungicides to dormant or frozen turf, and that's why I think the reason is. So we could probably set up some experiments to do that, but just from an anecdotal standpoint, the turf does not need to be actively growing for these snow mold fungicides to work. All right, so then just another poll here talking about fungicide timing. So, right, so this is a question that I get, one of my most common questions I get every year. And part of it is due to, the variable weather, right? So we have changing conditions that are leading to, some years we have crazy cold stretches in the fall, and other years we have crazy warm stretches, and in many cases we have both. And this year it's been mostly cold, but in past years we've had very cold snaps in October and early November. Everybody rushes to get their snow mold products out, and then it's 65 and raining come the first week of December. So really determining when to time that snow mold application is tricky. And so I'm curious to see sort of what people have to say on this timing topic, and that's sort of the result that I would have anticipated, right? 81% sort of You know, they kind of have a date in mind. Maybe they have a date penciled in on the calendar of November 1st or November 15th or something. And then that first kind of real stretch of cold, snowy weather that's in the forecast, they get out there and they put out that application. One of the problems, or one of the tricky things about that, is sometimes it's tough to prepare for that. Sometimes it comes on pretty fast, and this year is one of those years that it came on pretty fast. So one of the studies that we're working on, that's been funded by the Golf Course Superintendents Association and also our local chapter here in Wisconsin, is looking at the optimum timing for snow mold fungicides. Now, these are fungicides that are targeted for sort of the long snow cover duration areas of snow mold, not the areas like Northern Europe and Pacific Northwest where you might make repeated applications throughout the winter. And so it's a very simple study. We've done it for 3 winters in a row now, and it's 7 treatments. We have a non-treated, and then just Instructor applied at a 9.3 fluid ounce rate at various different timings throughout the fall. So what we did with this study is we selected 3 sites, one in northern Wisconsin that has very heavy snow mold pressure, one in central Wisconsin that has moderate levels of snow mold pressure, and then one here down in Madison that has low to moderate levels of snow mold pressure. And for each one of those sites, we selected a date that is sort of a traditional date of first snow cover. For the northern Wisconsin site in Minocqua, that was at November 1st. For the central Wisconsin site, that was November 15th. And then for the Madison site, that was December 1st. And then we just applied one application several weeks prior to that date that we pre-selected. So for the site in Minocqua, that 8 weeks prior to snow cover, that was an application on September 1st. We had no designs that would provide any control of snow mold, but the goal here is to find where in that zone is the most effective snow mold timing, and then what are some metrics that we can use to help us determine, rather than just our gut or our feel or the short-term forecast, on when is the most appropriate fungicide timing. This last treatment here, treatment 7, that's a floater. Right, so that we just waited as close as we could to the first significant snowfall, and we made the application. So that gave us some cover that if we applied the traditional timing on November 1st in Minocqua, but it didn't really snow until November 15th, that gave us some additional flexibility with that treatment. So just looking at jumping right into the results here over the 3 winters. The first winter we did this study was 2015 and 2016. And I'm only going to show the results for one site, Minocqua, because it's the only site we got really any snow mold at. Sites in Wausau and Madison got very little snow mold. So I'm just going to show the results for Minocqua right now. And 2015, 2016, the first winter of the study, you can tell there's sort of a break. We see more control at that October 15th date, which would be 2 weeks prior to traditional snow cover. This first year, though, it was on a weird angle, and we had sort of a lot of disease breakthrough on treatments even right before snow cover. You can tell the mid-November treatment even had quite a bit of snow mold. So in years 2 and 3, we moved it over to a different area, the same fairway, and we got much more consistent results. One note on this mid-November treatment, that's the floating treatment. I just put mid-November because in year 1, the application was on November 17th. Year 2 was on November 14th. Year 3 was on November 15th. So that we tried to time it right before snow cover, and each year it was very, very consistent to when that application was. So then year 2, 2016, 2017, we see a very dramatic cutoff in disease control between the 1st of November and the 15th of October. If we go to year 3, we actually see the same exact cutoff. 15th of October to the 1st of November. So if we look at when snow cover actually arrived here in mid-November, we're looking at anywhere between 3 and 4 weeks before that snow cover that was optimal. And I think why we see the breakthrough 4 weeks prior to when the actual snow cover arrived is there's just the elements are out there disrupting the persistence of the fungicide, allowing for rapid breakdown before the snow cover arrives and allowing pathogen then to grow and cause disease. So here's just some pictures of what the plots look like. The one on the left is 8 weeks prior to cover. The one on the right is 6 weeks. We don't really start to have any control at all until that 2 weeks prior to traditional timing, which ended up being about 4 weeks prior to snow cover. And so then here is the final 2 treatments, and these provided excellent snow mold control under really, really heavy pressures. So really, ideally moving forward, though, we're not talking about dates. We're talking about other environmental variables that we can measure to help us time our snow mold applications. And so at each of these sites, during each of these application timings, we also measured a whole bunch of environmental variables. And I'm just going to show you 2 of them right now. The first one is the 2-inch soil temp throughout the winter, and this is through 2015, 2016. The red line here is 16, 17, and then the green line is 17, 18. So if we were to recommend that maybe you apply, if we were to just go by 2015, 2016, and we know we got good control at this 1st of November date, maybe we say that at a 2-inch soil temp of 45 degrees Fahrenheit, you apply your snow mold. However, if we look at 2016, 2017, it was almost 60 degrees Fahrenheit at a 2-inch depth. And in 2017, 2018, it was at a 37 degree temperature. So soil temp is not going to be a very good predictor of optimal snow mold fungicide timing. The other thing then that we looked at that is a better predictor are what we're calling heating degree days. These are the exact same thing as growing degree days, except it's the opposite. We're adding up temperatures below a certain level. So for our work here, we used a base 50 temperature, and then anytime starting on July 1st of that year, anytime the daily average temperature was below 50, we added that up. So if the average daily temperature was 40 degrees, that day would have contributed 10 heating degree days to the total. And you can see this is much more consistent. Even though you saw before with the soil temperature wildly diverged, the heating degree days was much more consistent. So we can tell that, from our work so far at this one site, something around the range of a heating degree day accumulation of 100 is probably a decent indicator of when to apply your snow mold fungicides. The problem so far is that we really only got data from one site, and to really be able to test this and give good recommendations, we need multiple sites to be able to have confidence in this model. So we're replicating it again. We switched to some different sites, some additional sites, to try and see if this number of 100 applies for not only Minocqua, which is where this test was done, but for Madison and Minneapolis and Detroit and Toronto area, all these different climates. We want to make sure that it's a number that works over many, many different climates. All right, so now we'll do a real quick introduction into the various snow mold pathogens. There are 2 Typhula pathogens that cause gray snow mold and speckled snow mold. Gray snow mold is caused by Typhula incarnata. Speckled snow mold is caused by Typhula ishikariensis. Typically, we see Typhula incarnata in areas that have around 60 continuous days of snow cover a year. So this is sort of the southern Great Lakes, Madison, Chicago, Detroit, Cleveland. Southern New England typically will have more incarnata than ishikariensis. Ishikariensis requires about 90 days of continuous snow cover. These numbers are, of course, very, very approximate. But the more severe winters, the areas that really have snow cover from December 1 until April 1 with very few breaks, that is where we typically see ishikariensis. Differentiating between the two is relatively simple. Out in the field, incarnata produces sclerotia that are relatively large and red in the leaf blades. Ishikariensis produces ones that are relatively small and black. Almost looks like somebody sprinkled pepper on the turf. These sclerotia are the long-term survival structures of the fungus. They are produced in the spring following as the snow melts. They fall off the leaf material into the thatch, and they serve as the beginning inoculum the following fall. Typically, they start germinating and growing in the fall when soil temps reach about 50 degrees or so. So in Madison, that's around somewhere in mid to late October. All right, then the other primary snow mold pathogen that we have, or snow mold disease that we have, is Microdochium patch, also known as pink snow mold, also known as fusarium blight, caused by Microdochium nival. Does not require snow cover to cause disease. It certainly can occur under snow cover, but this is a really severe disease in areas that don't have a lot of snow cover, but it's consistently cool and wet. So we're talking the Pacific Northwest of the U.S. and of Canada, Ireland, UK, Northern Europe, Scandinavia, can be a very, very severe disease. Microdochium, unlike Typhula, produces a lot of spores, a lot of conidia, and these conidia can be easily tracked through traffic or rainfall or drainage. So if you have active Microdochium, you don't want to go walking through that area or mowing through that area. You're gonna easily spread that disease around the course. So one of the things that is important to know about snow mold, and what are the optimal conditions that lead to snow mold, and really it's all about temperature. What is it about the snow that leads to snow mold? There's nothing special about snow. What the snow does is it insulates the turf. And to illustrate this point, I'm going to show you the surface temperature results that we measured at 2 of our snow mold testing sites. One in central Wisconsin in Wausau that gets tremendous snow mold every year, and then the other one from Madison, where I've already said we get very, very little snow mold most years. So here we have the surface temperature throughout the winter of 2015 and 2016, and you can see very, very clearly where the snow cover falls, right? We had initial snow cover probably somewhere over here around November 18th. Then there was a break in the snow cover somewhere right around mid-December, and then we had sort of a snow cover around Christmas that stuck all the way through until mid-March. Right? So when I see a line like this, I know we're going to have good snow mold at that particular location, right? Because the fungi cannot grow when it's very cold. The fungi like temperatures right around that freezing mark. The other thing the snow does is trap moisture. I don't have it here, but under a good 5, 6, 7, 8 inch snow cover or snow depth, that relative humidity stays 75, 85% and higher. So we've got dark conditions, we've got cool conditions, but not cold, and we've got high moisture. Great conditions for snow mold to develop. If we compare that with the surface temperature conditions in the same year in Madison when we saw almost no snow mold, the temperature jumps all over the place, right? So it's kind of counterintuitive, but if you have a warmer winter or less snowfall, it actually makes things too cold for the snow mold fungi because you don't have that insulating blanket. So whereas the Wausau site, the temperature was right here at this 30 to 32 degree mark the entire winter. Here in Madison, we're getting all the way down to 10. We're jumping up to 50, back down to 15 below, or sorry, 10 degrees below freezing. It's all over the place, and it's not a consistent environment for the snow mold fungi to grow in. Snow mold fungi are slow-growing fungi. They don't do well with wild fluctuations in temperature or humidity. They need very consistent conditions because of their slow growth. So even if we have conducive conditions for snow mold for 2-3 weeks, oftentimes we don't see any snow mold develop because the fungi are just growing too slowly. All right, so one of the areas of research that we look at in my program is product testing, so looking mostly at fungicides. And this is a drone picture of one of our fungicide test sites. We do have really very large test sites. This particular one had about 120 treatments in it. And a couple things I always like to point out about this is here down in the lower right corner, this is a non-treated control, right? So really, really heavy disease pressure. But there's a lot of green in here. So what this tells me is that even though we have really heavy disease pressure, there's a lot of things that work, right? And so one of the main things that I always tell superintendents is there's a lot of options. You have a lot of options when trying to determine what is effective snow mold control for your area. So here's a picture of the great state of Wisconsin. We test at 3 sites, one way up here in Marquette, Michigan at Marquette Country Club, one here in the central part of Wisconsin at Wausau Country Club in Wausau, and then the other one is down here at our research station, or sorry, at Cherokee Country Club in Madison, Wisconsin. So I'm going to show one result from a couple winters ago from Wausau Country Club. And I'm just gonna pull out a few treatments, right? We had 120 some odd treatments in this particular trial. I'm not gonna bore you all with droning through each individual treatment. What I just wanna show though is that with these treatments, mixtures of multiple active ingredients is critical. If you have heavy disease pressure, there is no single active ingredient that will provide effective snow mold control. So here, the effective ones are all mixtures, right? Here's Interface Mirage. It's a mixture of iprodione, trifloxystrobin, and tebuconazole, right? So 3 active ingredients. Here is Torque, which is tebuconazole on its own, not providing very effective control. Here's iprodione on its own, not providing very effective control. The products that have mixtures of 2, 3, sometimes 4 active ingredients are the ones far and away providing the most effective control. The one thing I will say is I want those mixtures normally to be from different chemical classes. So, and if you have gray snow mold or a speckled snow mold at your site, one of those classes should be a DMI. The DMI fungicides are the most effective as a class against the Typhula fungi. If you want to look through the results, we have all of our snow mold results posted online at our webpage, which is right there in the corner, tdl.wisc.edu/results. We've got snow mold results for the past 10 years on that webpage. I encourage you to look at that website, look at those results, find combinations of active ingredients that work, and then find a price that works for your budget. The other website below that, turfpests.wisc.edu, that's another site. It's a newer site that we have developed in collaboration with Aaron Patton at Purdue, with Paul Vincelli at Kentucky, and with Bruce Clark at Rutgers, with a sort of efficacy ranking of various fungicides against diseases and herbicides against various weeds. And this will be updated on a yearly basis in collaboration with Drs. Patton, Vincelli, and Clark, and provides you a nice a ranking and sort of a quick overview of what are effective pesticides against certain pests. So just another tool in your toolbox. All right, so just a couple of pictures from the trials at Wausau. There's the non-treated, totally hammered. We have Interface Mirage, effective control. Torque, a lone active ingredient, just does not hold up in heavy pressures. And then there's Instrata through a mixture on the right, providing very effective control. Same thing here, iprodione, 2,6-T on its own. Normally, iprodione is considered a very strong pink snow mold product. This is mostly pink snow mold at this site, but on its own just can't hold up to that heavy pressure, whereas the Concert and Turfside mixture to the right providing very effective control. Just by sort of pure luck in this trial, we had a nice illustration of what happens if you take out certain pieces of that mixture. So here's Interface Triton providing very nice control of pink snow mold at Wausau. So if you just take out the Triton, if you just take out the DMI, you lose almost complete control of that combination. So then you might look at that and say, well, then that must have been the Triton that was doing the heavy lifting. But if we take out the Interface, the Triton is just as bad alone. So it's the mixture of all those active ingredients that really provide the control. Same trial, another example. Here's Torque plus 2636. That's tebuconazole plus iprodione plus thiophenate methyl. All 3 of those together, excellent control under heavy pressure. If we just take out the 2636 and go with the DMI, we lose almost all the control from the mixture. If we just take out the Torque and go with the 2636, we lose almost all the control we were getting. So there is no single active ingredient that provides effective snow mold control under heavy pressures. Important to mix those various classes together. Last winter was at Marquette Country Club up in Marquette, Michigan, was probably the most severe snow mold I had ever seen in any of our trials that we've done over the past 13 years or so. And here's a picture from the trial. I mean, just from plots that are completely obliterated to plots that look, that look like they're in mid-season form. So the interesting thing to note, though, is that a lot of the same things apply. You still need mixtures of multiple active ingredients. So here's the non-treated, really way up there at 100%. And we're seeing a little more snow mold than we saw at Wausau, a little more of a moderate level of pressure, but the same things apply, right? You need that 3 or more mixtures of different active ingredients from different chemical classes to provide that increased level of control. One thing I will say that we've noticed is that PCB on its own, not an effective snow mold control product under heavy pressures, but it's a very good take mix partner. So if you've got very, very heavy pressures and you're still seeing control even with 2 or 3 active ingredients, putting in a rate of PCB can provide some increased efficacy in the U.S. It's not available in Canada or elsewhere in the world, only available in the U.S.
And so, Paul, this would be the part of the presentation where I say the label is the law, because you do have to know what you're allowed to apply, where you're allowed to apply it, what it's registered, your state, your country, what have you. You as a researcher have a little flexibility, but it looks like all of these trials you're actually using product in the way in which they're labeled, correct?
Yes, that's correct, Lisa. We're not using any, sort of flexibility that a researcher can sometimes have. These are all labeled rates. These are all labeled mixes. All of these products, just scanning them, are available in the U.S. Not as many of them are available in Canada or in other countries, but these are all legal uses of the products. Thank you for pointing that out.
Hava likes me to do that.
Excellent. So just a few quick pictures. There's the obliterated, non-treated. Trilogy providing good control, not as good as it has in other trials. Instrata plus Turfside, again, just sometimes under really, really heavy pressures, putting in a relatively low rate of Turfside or PCNB can provide a great increase in control. And there's another example, Concert and Turfside. All right, so sometimes good products just don't work that well. So, what are some examples and why is that? We have an example here from Marquette Country Club, one of our trials in 2013-2014 versus 2014-2015. And I just pulled out 3 treatments. In 2013-2014, we had very high levels of pressure, and the Instrata did not perform as well as we would have expected, but the Interface and Triton did perform very well. And as you can imagine, the Syngenta people were not thrilled with this result. The Bayer people were thrilled with this result. Now, if we go to the very next winter, we see the exact opposite happen, right? Same rates, same products, Instrata performing extremely well, and Interface and Triton not performing as well. So this year, obviously, 2014-2015, Syngenta was happier, Bayer was less happy. The point is, this is not to point out that Syngenta's happiness or Bayer's happiness. It's that good products sometimes just don't work. They don't work as well as we expect them to. And it's not because they're bad products. It's because we expect a lot out of these products, right? We typically apply them in, late November, early December, and earlier in some cases. And we want them to last until April. That's a long level of expectation. One of the things that sometimes can lead to these problems is degradation early in the season. So here, this was from 2015. I know many of you in the U.S. and in Canada remember this December. It was incredibly warm and incredibly rainy throughout the entire month of December. We had people mowing their turf in December. There was just a lot of concern over whether the products that we'd applied in late November were still going to provide protection throughout the course of the entire winter. And we've done a lot of work here in Wisconsin on how different winter conditions impact persistence of snow mold fungicides. And so, our 2 objectives were determined. This was a study that was funded way back in, I believe, 2008 through 2010 by the Golf Course Superintendents Association of America in collaboration with our chapter here in Wisconsin. And we just wanted to determine the persistence of iprodione and chlorothalonil under continuous snow cover and in the absence of snow cover, and then determine what concentration of those fungicides suppressed Microdochium in the growth chamber. Our hypothesis here was that the lack of snow cover will lead to faster fungicide depletion, right? So if there's no snow, the sunlight is gonna degrade those plants, degrade the fungicide faster. And so I'm going to move through some of these slides pretty fast so we can talk about the results in a little bit of depth. But here is just kind of a cartoon of how the plot looked. We had plots kept under continuous snow cover, other plots that we continuously shovel the snow off onto the snow-covered plots. Here is what that plot looked like in the middle of the winter. So we applied the fungicides. We would make our initial application, and then anytime it snowed, we would shovel the snow off of the non-snow plots onto the snow-covered plots. We would go out there and we would sample 2 plugs per each plot. If the ground was frozen, we would need to pull out the heavy-duty drill and then hammer those frozen plugs out of there like a kind of like a frozen hockey puck using a crowbar. And one of those plugs would go to the lab for fungicide analysis, and then the other plug would go to the growth chamber and be inoculated with Microdochium. So what we should be seeing is that as the fungicide concentration goes down, is degraded, we should see more and more growth of the fungus in the growth chamber. Once the snow arrives and once we need to get the plugs out of these snow-covered plots, it gets trickier, right? We hire an undergrad that, you know, we throw into these deep snow holes and have those plots get pulled out. So we did this work over 4 years. I'm only going to show you results from the last year of this particular study, 2012, 2013, just in the interest of time. And what I will say is looking at both chlorothalonil and iprodiol, this was a very wet winter for us in Wisconsin. We had a lot of snow cover. We also had a lot of rainfall events. So if we look at the bioassay, this is the amount of disease in the growth chamber from plugs that we sampled out in the field. So we sampled the plugs in the field, we put them in the growth chamber and inoculated them with disease, and over time we saw an increase in disease. But basically what we saw is not a continuous increase. We saw no disease develop on these plugs until about mid-January, and then a very rapid increase in disease. Now these are plugs taken from these snow-covered plots. If we look at plots taken from the non-snow plots, we see the exact same pattern. So no difference from snow and non-snow on the level of disease increase throughout the winter in 2012, 2013. Now let's look at the actual fungicide concentrations. What we found is a very similar pattern. From the snow-covered plots, the concentration stayed similar until mid-January and then rapidly dropped off. Same thing under the non-snow-covered plots. All right, what about iprodiol? We see a very, very similar pattern as the chlorothalonil. So here's the bioassay. There's really no disease on these plots for most of December, for the first month after application, and then it increases rapidly in mid-January. And we see the same thing from the non-snow covered plots, right? A rapid increase throughout the entire month of January in disease in the growth chamber. What about the iprodiol concentration then? We see a relatively rapid decrease in concentration from the snow-covered plots, and then the non-snow-covered plots were a little more similar to the chlorothalonil, where it's consistent throughout most of December and the first half of January, and the concentration fell off very rapidly. So right, this is very interesting, right? So there's clearly something happening in mid-January that's leading to a rapid degradation in the fungicide, which is leading to a rapid increase in the disease in the growth chamber. So here is the soil and air temperature from a non-snow-covered plot from the research area. And right here in mid-January is sort of our time of interest. And if I go back and I look at our records, you can see these three peaks in air temperature here. These are all correlated with significant rain events. All right, so what I'm concluding from this 1 year of the study is that the rainfall is what led to the rapid degradation in the fungicide, which is what led to the increase in disease. And I can tell you we saw the exact same thing in the other 3 years of the study. Anytime there was a rain event, it would rapidly degrade the fungicide, which would lead to increases in disease in the growth chamber. Until then, it didn't matter if there was snow or present. So there was really no impact of sunlight on fungicide degradation. So if you applied a fungicide for snow mold on December 1st and there was no snow and it was below freezing and you didn't get any snow cover until Christmas on December 25th, that fungicide would stay present on the leaf blades. Right? So it's really the presence of winter rainfall events or snowmelt events, that moisture flowing through the area, that led to rapid degradations in the system. So the conclusion here, snow cover did not really have an impact at all, so we rejected our hypothesis. The bigger impact was from winter rainfall or snowmelt events. We also did see an impact of temperature in 1 year. There was a warm spell that didn't have any rain, and we did see a decrease in fungicide persistence in those areas. We are following up on this study. We're in the third winter now of a follow-up study funded by the Canadian Turfgrass Association, looking at propiconazole, chlorothalonil, and the impact of transference as well, looking at transfilm and seeing if that increases persistence. And we're doing the analysis on some of the results right now. What I can tell you is that we saw almost the same exact results from the first 4 years of the study. They persisted consistently until there was a rainfall event or a big warm-up event, and then the fungicides degraded relatively quickly. All right, so what I don't want to happen as a result of this research is that anytime it rains after you put out snow mold, or anytime that there's a warm spell during the winter, that everybody goes out and they reapply their snow mold fungicides. Because that's not what needs to happen. And it comes back to the old disease triangle, right? So the disease triangle says that you need all three of these points to have disease. You need a susceptible host, you need a virulent or aggressive pathogen, then you need a conducive environment. And so what we're typically missing during the middle of the winter is a conducive environment for a disease to occur. And to sort of illustrate this point, I've sort of made up this graph of theoretical snow mold fungal growth, right? These numbers don't mean anything. These numbers over here on the left, right? They're just numbers I made up. And let's say now that, you know, the amount of snow mold fungi required to cause symptoms is at this level of 25. So if we have a non-treated plot, right? It's going to start growing somewhere in the late fall, early winter, and it's going to, over time, if the environment is conducive, just grow, and eventually get on the plant, get inside the plant, and going to cause symptoms. Now let's see what happens with a treated, right? If we spray a snow mold application here somewhere in mid-November, we have knocked back the fungal population, right? Even though it's not snow-covered, those snow mold fungi are starting to wake up and grow, and if they're actively growing, we know that the application of the fungicide is going to have an impact on the fungal population. So even if we knock it back, the fungus will start to grow and recover, but the question then is, does it get back to the point where it actually causes symptoms? So typically when I talk to superintendents, even if it rains 3 days after you make the application, you have still knocked back the population, the fungal population. It's much better to have your application persist for a month or two into the winter so that the starting point for the regrowth is over here in February than it is in December 1st. But even if you've made that application, you have knocked back the population, and it's going to be rare that you would need to make a reapplication. It's going to depend on the environmental conditions. It's going to depend on how early that rainfall or degradation event was. It's going to depend on how conducive your conditions are going to be during the winter. But in most cases, you won't need to reapply because of the impact that your application had on the fungus right when you apply it. All right, so there's a whole bunch of snow mold work that we still need to do. It's it's a job security aspect of somebody that works in snow molds. I already talked about optimal timing of snow mold fungicides. We're working on that. What is the optimal carrier, right? This is a time of year applying snow mold that is typically you're understaffed. You're trying to get a lot of stuff done before things freeze up. If you can go on a lower carrier and bring the tank back into the shop to fill up less times, that's going to save a lot of time. What about fungicide alternative products? Some of the work that John Dempsey has done in Ireland and the Oregon State team of Clint, Alec, and Brian, they've done some great work looking at phosphites and sulfur and oils on control of snow mold in those areas. We have not seen those same products be effective in our areas where you have the long duration of snow cover. We've tested them, and we have not seen them be effective unless they are tank mixed with an effective fungicide mixture. So I think we need to do some more targeted research in that area to see why they're not working and what are some reasons we can, or what are some ways we can improve their efficacy. And then are there biocontrol efforts? I know Dr. Zhang in Guelph in Canada had some effective biocontrol products that were in development. Can we use microbial populations to manage snow mold? There's some excellent research there. And then what about some other environmental factors and modes of action that impact snow mold fungicide persistence? Other areas that we can certainly work on. So with that, that's all the content that I had for the webinar today. Here is my contact information. If you have any questions on snow mold, please do get a hold of me either through email, or feel free to contact me on Twitter or contact my cell phone. I know some people don't feel comfortable calling a cell phone, but that's what it's there for. So go ahead and call or text if you have a question. And there are those two websites again. If you want to look over our results from our past research from snow mold and our summer trials, tdl.wisc.edu/results. And then the other one looking at efficacy rankings for different turfgrass pesticides, fungicides, herbicides, insecticides. That website is turfpests.wisc.edu. We'll be updating that with the latest research and hope to release that by April 1st of this upcoming year. My final note then, of course, the picture on the right, you got to remove the pin to get full, complete snow mold control on your green. So always remember remove the pin. So that's all the information I have. Wish everybody a Merry Christmas and a great start to the season next year, and look forward to seeing people out on the conference and meeting circuit around the country and elsewhere over the winter months.
A lot of great info there, Paul. We really appreciate you presenting today. There's a question here, and please, anybody else have questions, type them in or raise your hand. Do you have any research with covers? And if not, would you assume that you would not have as much degradation because of protection from rain?
So that's an excellent question, and that's another thing I could have added into the smorgasbord would have been looking at the impact of covers on snow mold. And I'll get to the question in a second, looking at impact of covers on degradation. But the impact of we did test the impact of covers on snow mold severity, how bad the snow mold pressure was. And what we found, we tested impermeable green jacket versus a permeable evergreen versus no cover at all. And what we found is that we didn't see any appreciable increase in snow mold with the evergreen compared to the no cover treatment, but we saw about twice as much snow mold under the impermeable green jacket as we saw with the evergreen cover and the no cover. So if you use an impermeable green jacket cover, we still could control snow mold under there. We said we need to make sure that we had a very strong snow mold program underneath that. As far as whether it would prevent degradation, very possible. If you're gonna keep water from flowing over those leaf blades by keeping the rainfall off and the snow melt off, yeah, I would imagine that would elongate the persistence of the fungicides on those leaf blades. So it would need to be an impermeable cover, though. A permeable cover I wouldn't imagine would have any impact. The flip side, though, is if the cover is significantly warming the turf so that it's above freezing, then you might actually stimulate growth of microbes that then would biodegrade the fungicide. So I still think that you probably see a longer duration of fungicide under the impermeable covers than not, but you might actually increase your biodegradation under there.
That's interesting. We had a winter roundtable discussion a couple weeks ago, and of course the covers was one of the items that they talked about. We want to thank PBI-Gordon for sponsoring this webinar. It has been approved for external education points, and so you're going to need to enter this code on the GCSA website to get those education points. 999-22210-29198 is the code that you're going to need to enter. Very easy to do once you get there, and we thank PBI-Gordon for making this event possible. We do have a number of other webinars coming up in December. One of them is tomorrow on ABCs of Irrigation Design, so you can join us for that. Value of Volunteering. Trent Manning is going to talk a little bit about things he's learned when he's volunteered at other facilities. Beth Gertal will talk about what's really in that fertilizer, which should be an interesting one, part of our ASCS prep series. Kicking off 2019, Leading from the Turf Up. Leadership webinar that's going to be taking place. GIS, as we mentioned, San Diego coming up soon. You can visit the PBI-Gordon team, meet them firsthand, booth number 3436 on the trade show floor. We're also going to have seminars right on the trade show floor this year in some specially constructed areas, so that will be an interesting event. You can look more at free sessions. Here's just a sampling of things that are going to be taking place on Tuesday. Lots of easy ways to look at content, speakers, tracks, dates, free education seminars for additional education points. Last but not least, the GCSA podcast. If you haven't listened, I encourage you to do so. We have a couple of episodes now available. Some interesting content there. I am not seeing any other questions. Do you have any closing remarks for us, Paul?
No, not really. I mean, just some of the things that we talked about before. One thing I will say is I always like check plots. Right, leave an untreated area, small untreated area, to give yourself an idea what your pressure is for your site, and then that would allow you to determine the level of protection that you need. It's always nice to know what would happen if you did nothing. If there was a lot of snow mold, that's a teaching tool for your course to say, hey, this is why we spend $10,000 on snow mold. If there's no snow mold there over a 5, 6, 7, 8 year period, then you can probably adjust the amount of snow mold protection you're putting out. So I always like to see check plots. They're a great research tool, but especially for snow mold.
Makes a lot of sense. Thanks, Paul, for presenting today. Appreciate it.
Thank you, Lisa, and thanks to PBI and GCSAA.
Absolutely. You'll all receive access to this recording via follow-up email in the next couple of days. So we thank you again and hope everybody has a great day. Bye now.